Good afternoon and welcome to Managing Collaboration Between Electrical and Mechanical Disciplines. My name is Kevin Holbrook. I'm one of the Technical Solutions Specialists here at CAD Dimensions. Before we get started, a couple of housekeeping issues. During the presentation, if you do have any questions, please post those in the questions section of the GoToWebinar. I will, at the end of the session, I will go back and answer any open questions that we do have. Now, I get the luxury today of talking about a topic that is somewhat unique because when you think about mechanical design using SolidWorks and you think about what your organization is doing for electrical design, traditionally there's a disconnect between those two, and we can almost, in some cases, call them separate sides of the business. So before we get started on the presentation, I just have a couple of questions back to you. First of all, if you look at your mechanical design requirements, so what you're doing in SolidWorks today, are you required to integrate the electrical aspects of that mechanical design? You know, pumps, motors. Do you put in circuit breakers and fuses and switches and those types of things currently within the system? Go ahead and if you wouldn't mind just voting on that. I'll give you a second here. So if we look at the results of that, it's about 50-50. Some of you have to, some of you don't have to. And when I think about this question, you know, if you don't have to, would it benefit you if you did? Okay, think about that for a moment. So in your organization, who is responsible for your electrical design? And the reason I ask this, some mechanical engineers are also doing the electrical work as well. So if you wouldn't mind just voting on this. Give you one more second here. All right, I'm going to go ahead and share this. Looks like a majority of the folks online have an electrical team. Looks like in some cases, I think other could be outside resources or other contractors that may be doing panel design or electrical design for some folks as well. One last question, and this one's kind of the focus of our presentation today. How does your mechanical and electrical designers collaborate? Now, I obviously couldn't come up with all the different ways that that you collaborate, but there's no clear method. Okay, you can see some folks have integration meetings, and when those integration meetings happen, differ depending on the organization. Some are just exchanging drawings, saying, okay, we need these components, here's the electrical drawings, and make sure they get into the mechanical design as well. Let's go ahead and show you kind of the results of this, and this is the reason we're here today, is to really talk about how the SolidWorks tools can allow your mechanical and electrical designers to collaborate. Now, I hope most of you folks did get the chance to attend this morning's session. This morning's session was focused on the 2D side of SolidWorks Electrical. Well, I'm going to focus on the 3D side of SolidWorks Electrical. What it's like to be a mechanical designer in SolidWorks and working with somebody who has electrical 2D. What can we do to take advantage of the tool to make it easy for us to do our job and integrate within it? So as with all the other products that SolidWorks provides, you know, it's kind of all in that grouping, you know, from simulation to composer to the design tool. Electrical fits right in there. And when I say it fits right in there, it will work right inside of SolidWorks. We can manage the data inside of Enterprise PDM. So it's one of those pieces that we can plug in and work directly with, just like all the other SolidWorks tools. Now, what I want to cover today, I'm going to keep it real light on the PowerPoint, but I do want to kind of set things up as to where the electrical 3D product does fit. Talk a little bit about typical electrical mechanical process, issues with that process, maybe a new process proposal, and then we'll look at the products and actually run electrical 3D and show you what that might look like. So here's what we're seeing today. Very typical. The 2D electrical user is going to create the schematics, the line diagrams, the work that they need in 2D electrical. The mechanical designer is going to do the layout of the mechanical side of things, and then as we mentioned before, we have some sort of integration meeting or some sort of communication that allows you to then take the two pieces and put them together, but it happens late in the process. And then you have to document everything for manufacturing. It's a very serial process. One thing waits on the other, or maybe not. Sometimes mechanical design gets ahead of electrical design. Sometimes electrical gets ahead of mechanical. We'll talk about that as we go through this today. Now, what are some of the issues with that? First one, you have a separate bill of materials typically for mechanical and electrical designs. So if you're looking at full cost estimation of your product, again, there's some more work to work up everything there. When we talk about the design collaboration that exists between the two, it's meetings, it's conversations, it's passing a drawing. There's really no true collaboration currently, unless you've gotten really unique in your process. The integration of the two systems, as I mentioned in that serial process, is typically an afterthought. You don't plan the paths for routing electrical as efficiently as you wanted to. So sometimes when you start to put equipment together, you maybe have to reroute things or wire it a different way because you don't plan for the electrical side. And it's hard when you got many phases like electrical and hydraulics and pneumatics and the different individuals that work on those, getting them all coordinated together. So what we're proposing with electrical and electrical 3D is to take that process and to start to integrate your electrical design in your mechanical design much earlier in the process. Document it, manage it, and integrate it all in one shot. Again, cutting back that time that you need to complete your designs. So when we deal with electrical products, hopefully you saw this morning the 2D electrical, and we have the 3D electrical product. Now I'm going to focus on 3D electrical. Kind of visualize it this way. It's that piece that bridges the gap between the 2D electrical and the 3D electrical. It's that synchronized system design. Now, if you didn't attend this morning's SolidWorks Electrical 2D, that tool is intended for the 2D schematic, line diagrams, panel layouts. With 3D electrical, here's some of the things that we can look to get. First of all, we're going to leverage the schematic that the electrical team has already put a lot of time and effort into. Okay, we're going to keep an eye on that electrical design. If things change, if components get added, we're going to know about it. Now, we can virtually plan all our paths and routes. We can avoid issues with other subsystems. What this helps you to do is to create more consistent product assembly documentation and manufacturing later on down the road. You know what the length of the wire is going to be, you know what it's going to look like, and you know where it's going to be routed. Another big aspect to this is having a unified bill of material, getting those costs associated with understanding the electrical and mechanical components. And then organizing it later on for simulation. Think of the other things that you do like flow simulation, mechanical simulation, and understanding what other areas inside the mechanism have wires and harnesses within those. Okay. Think of it another way is think of it this way. Think of the electrical components that we add to our SolidWorks assemblies. That's what we're focusing on today. When I talk about bill of material unification, this is a good image that helps us to understand that. A lot of times today when we're doing mechanical design, we leave out some of the electrical components or we leave out some of the pneumatics. In this case, we allow us to take advantage of what's been done in the 2D to put all of that together into our assembly so we have a full bill of material. Okay, so let's take a look at the product. So electrical 3D is just one aspect, obviously, of SolidWorks Electrical. The other is the 2D. The neat thing about this is it's all connected in a collaborative environment. There's actually a server where the 2D electrical user and the 3D electrical user connect to. So it's real time. Now what you're going to do on the mechanical side is you're going to start to work with existing projects that your electrical designers have started. Now here you can see I have multiple projects available to me, and I can choose to open those projects directly inside of SolidWorks. Now SolidWorks Electrical 3D is just another add-on. When you turn it on, you have toolbars, and you have another tab over on your task pane for the project documents. Now what you're seeing is a folder or book layout for an existing electrical project that includes cover pages, drawing lists, and some other things that you might think that are quite unique to a project, such as adding other PDFs or other documentation that you might need. Now, what's neat about this is I have the ability as a mechanical designer to go in and look at the 2D electrical design, the most current design. This is really just an image. I can't change it, but I'm able to get in and see, okay, here's the motor starter circuit that we're looking at for this particular design. And I have access to that. Now what you're seeing is just how it was organized. Now on top of that, we have our SolidWorks files associated with this, because not only are we wiring up a panel, but we're also managing the SolidWorks file associated with that. And that's also stored within the project, and I can go ahead and open that automatically from here as well. Now a couple of the things that you'll notice now, our Command Manager now has electrical 3D options associated with it. I can go over next to my Display Manager. We have something called the Electrical Manager, which manages all the components as part of the electrical design, and I'm going to come back to that in just a moment. So as we go through this process, let's look at some of the typical things that we do inside of SolidWorks. First of all, we create 2D drawings. So I'm going to just let the software create a 2D drawing of my unfinished panel. This panel's been started using the schematic tools that are available. So we'll go ahead and start our SolidWorks drawing. This is stuff that we're all used to at this point. We'll go ahead and maybe add a bill of materials to this. And we'll go ahead and balloon this because we want to see the process of getting this up to date. Okay, we'll go ahead and auto balloon, and everything's coming in just nicely. Now, as I go back to the assembly and continue my design work, when we talk about collaboration, we really have to understand what's been done since our last change or last edit to this assembly. Now, in order to collaborate with the electrical group, we have the electrical manager off to the left-hand side. Now, what this is a list of all the electrical components that have been added in 2D electrical. If I expand any of these components, you can actually see the type of component it is and whether the component has been added to my SolidWorks assembly. If there's no checkbox, it has not been added. I also have a nice little tool to hide any components that have already been inserted. You'll notice that I'm missing a DIN rail here. I can go ahead from here and tell the software I'm ready to go ahead and insert that horizontal DIN rail, and I can go ahead and place that into my assembly. It automatically brings up some of the mating tools that we have in SolidWorks, but here's where it starts to get unique to an electrical experience. I have the ability to modify the length of that rail on the fly. If I wanted to make it a little shorter, a little longer, I could do that automatically on the fly. Now there's a couple other components that we need to add here. I need this magnetic starter. Now in some cases the software, as it did with the dim rail, knows exactly which component to go get out of my library. We're going to talk about later how we might affect that. So as I right-click on a component that hasn't been added, I can go ahead and drop that into my assembly. The one thing I want you to notice about that is that the component automatically snapped itself to the DIN rail. Okay? So here's the process of us taking a look and seeing what the 2D electrical designer has already done and adding those components to my electrical assembly. But that's not always how it works. Sometimes your mechanical group gets ahead of the electrical group. In other words, you'll add motors, you'll add light curtains, you'll add switches, you'll add things to your assembly that have yet to be wired within the system. Well, that's very easy. I can go ahead and insert components like I typically do. We can browse to what we want to add. In this case, we're going to add an emergency switch. We place it into the assembly the same way we do any other component in SolidWorks. There's nothing new there. I can go ahead and position that component within the assembly and orient it properly. Once I have it oriented, this is where the communication process comes into play, because I have yet to let the electrical group know that I've added a new component that needs to be wired up. So what I can do on the mechanical side, very simply, is to add that component. Now, adding a component is your way of communicating back with the electrical group. Within electrical, we have a library of components. Those components contain some of the 2D electrical symbols that will be used for the 2D users, but it also contains some tools and items that we can utilize on the 3D side. Everything is organized by class, so I can go ahead in this case and select the class of component that I want to add. This is a signaling alarm, a luminous signaling alarm. I can go ahead and select that. If I happen to know the next mark that we're going to use, I can put this in here, but this is something that can be edited on the other end. And we can also put in things like descriptions, so we can make sure on the other end they can have an idea of what we're dealing with or what we've added. Now, on top of that, we can also tie in an actual manufacturer of the part that we're going to add in this case. So we have the ability to search an existing database for different manufacturers of these types of components. If I happen to know the reference number, I could go ahead and type that in and physically search the database, and here I have a emergency stop indicator from Legrand that I can go ahead and add to the system as well. Okay, and this just tells the electrical designer what we're actually using as a manufacturer, so he can do any research that they need to do along the way. Now, I have some other components that I need to add to the rail here. One nice thing is I can go ahead and select multiple components and go ahead and insert them. I can also change the order in which I want to insert them, and just like the components that you saw before, they'll snap to the DIN rail, and I'm going to show you a little bit later how that gets done. When you're placing multiple components, I can even set the spacing. So as I set the spacing to 0 here, you can see that it's went ahead and spaced the circuit breakers directly next to each other. But at any point in time, I can come back in here, and using a tool inside of 3D Electrical, I can go ahead and respace components because of heat requirements and so on. So I can go ahead and respace that. Now, I've done all this work like we typically would in SolidWorks, and I have an existing drawing. If I jump back to that drawing, you'll notice that the new items are automatically added to my bill of materials. I may have to come in here and add a few balloons within that, so we'll go ahead and balloon a couple of the items here, and I can use my spacing and everything else that we have available to us. Another thing that we have available on the drawing side of things is the ability to grab the mark data. I can go ahead and create marks within the system so that it grabs the component names and the marks associated with that, and it places them on the drawing. And again, I can control the fonts and so on. Now, when you think about collaboration between the mechanical and electrical, this is a mechanical drawing, but we may want to communicate it with the electrical team. And the electrical team is working within this electrical project that we have here. So what if we could take any view, any drawing inside of SolidWorks and actually create it as a project drawing? Well, I can go ahead and take this physical drawing and create it as a project drawing inside of electrical, and now when they're in the 2D electrical tool, they'll have access to this same drawing as a static image that you would expect to see. Okay. Now, back to our assembly. One of the reasons we talked about having 3D integration was the ability to get your routing and your paths of your wires and cables set correctly before you ever finalize your design. Now, some other things that we have at our disposal to help us with this, we have a tool called the Segregation Manager. What this does is it helps me to determine if I want certain wire types to go through certain channels within my design. Okay, in this case, I can run high power to one side, all the low power to another side. A way of doing what the manufacturing group would typically do on the shop floor, so you route things correctly along the way. Another thing that we have is we have what we call a routing path. We create a sketch as a guideline to the system to say where I would like to route my wires. When I do those things, I'm able to come in here. I'm going to select a few components in this case, and I'm going to be able to tell the software to go ahead and route wires. Now, routing these wires uses and takes advantage of SolidWorks routing. If you've used that in the past, it's the tool that allows you to create pipe and tube and electrical harnesses. Now, this takes advantage of that. We can now create 3D sketches for all the components I've selected, and the software is now physically going to use the routing sketch to run the wires through the channels and make the proper connections to the components within the system. Now think about that. Now you have wires that run from the connection points on all the components through the proper channels to the proper location. Now what I can get out of that, if I go back to my project for a moment, we have our bill of material and our wire lists. When I go to my wire lists, it automatically gives me the length information for each of the wires. So when you think about waste, when you think about purchasing and getting the proper amounts of wires, you have some more resources to you to assist in making that a reality. Now I want to talk a little bit about how we make this automation happen, just real briefly. One of the things that we're able to do, as you saw when I drag and drop a component in, it snaps to the rail. Well, how do I make that happen? Well, the first thing that we do is we find the component that we're looking for. In this case, let's say this magnetic starter component. And with SolidWorks Electrical, we have what we call the Electrical Component Wizard. It makes it real easy to find something out on the website and download it, put it in your enterprise PDM to be managed as a library, and now we can make it an intelligent electrical component. Now, a couple things that we give it to help with spacing, to help with routing of the wires. The first one is defining the left, top, right, and bottom faces. This is all for spacing. So we're basically giving the four outer faces on the component. And this is a wizard, so as I provide that information, it kind of works to the next thing. Now, for those of you using SolidWorks, you're familiar with mate references. Well, we use mate references to snap to the rail, yet Electrical Component Wizard helps me to create those mate references. So all I have to do is give the software where the top face of the rail is going to be and with the front face. So it's going to connect the two together when I drag and drop them on. Now, the last and most critical piece of this has to do with the actual connections. When your 2D electrical user creates a schematic, they look at the different circuits relative to a component. And those circuits correspond with connection points on my 3D model. So if I wanted to create a connection point in this case, what I would need to do is create a sketch that contains a point. Okay, I'll go ahead and show this. So I select the point that the connection is going to come into, specify the circuit number and the connection point, and it goes ahead and creates the connection for me. Now this number is what gets called out by the 2D guy so that it knows exactly where that wire needs to come in. Okay, and I can go ahead and do this for the two missing connections that we have. Okay, once you have this done, that's all we need for the wizard for an electrical component, and this thing is ready to be used in electrical 3D. So it's very easy to either create your own component or download to do that. Now, another aspect that I wanted to talk about, just to clarify my presentation today, we also have that whole idea of this manufactured parts. When you saw me pick the Legrand part number here, but this all comes from a parts manager database with all those classes of components that we're dealing with here. So how do I add something in there? If I'm a mechanical guy and I now get a new motor that we don't have in the database, I got a new 3D model, the electrical guy doesn't know anything about it yet because it's something new. So how do I go ahead and add that to the system from the 3D world? Well, I can go ahead and use my add part command, and I can specify what the part is. And this happens to be a Hayden-Kirk stepper motor, so we'll go ahead and give it some part number or identifying information. This is a Hayden 20,000 captive stepper motor that we're dealing with here. Now, there's some other information that we can put in here down to the bottom, like get down here a little bit. All right. Oh, it's looking for the manufacturer first. If you don't have the manufacturer and you just type it in, it's a Hayden-Kirk. What class is it? You know, we'll put it in the motor class in this case. Okay, and I can put in voltage, frequency, some control information. But here's the important part for the mechanical team, is I now can associate a 3D part from my library, the part that I set up. So I can select in here, go to the part that I'm using in my library, and tell the software, okay, you know what, here's my stepper motor. Now, that's what creates that relationship when I add the component in 2D, that it automatically knows what to add, like the DIN rail and the magnetic starter that we added before. So I hope you liked the presentation today. I wanted to focus on the 3D side of things, how we interact with the 2D users, the 2D electrical schematic design. I understand this is kind of something new. You don't really have these types of tools elsewhere, but hopefully this can create a more collaborative environment so you can go in and utilize the 2D electrical users' work to integrate directly into 3D. So if there isn't any more questions, that's all I had for today. I hope you enjoyed the presentation, and we'll see you on the next one.